Hey IB Environmental students, we're starting topic 5.7, urban air pollution. Make sure you have your objectives ready. Let's go. Okay, in class we learned that there are two major types of pollutants previously, even before this unit, called non-point and point source pollution. These are not quite the same exact things, and I'll try to interweave those previous terms with these. So the terms we're learning now are called primary pollutant and secondary pollutant. A primary pollutant is something directly emitted into the environment. And it hasn't gone through any chemical reactions. For instance, nitrogen dioxide will be emitted from car emissions, and that's something we can directly put into the atmosphere. Now, this is, even though this sounds kind of like it's going to be point sources only, this is a non-point source emissions because we don't know exactly what cars. On the other hand, secondary pollutants are things that have gone through chemical reactions. They usually would have involved the primary pollutant originally, and it'll interact with other factors. For instance, that nitrogen dioxide from the cars will combine with water through a chemical reaction and form this nitric acid, which is a type of acid rain we'll learn more about in future parts of this unit. Okay, so the difference is chemical reaction or not. Let's focus on ozone. The big thing you need to walk away here, because we're going to do a full depth unit on ozone, is that ozone can be good and bad, and that's dependent on what layer it's in. And you do need to know these two different layer names, stratosphere and troposphere. So ozone is oxygen with 3 atoms. Normal oxygen that we breathe is oxygen, 2 atoms, diatomic oxygen. Ozone is going to form when this diatomic 2 oxygen molecule interacts with 1 oxygen atom. We'll talk about later how that 1 oxygen atom formed. It can be found in 2 of the different layers. In the stratosphere, we call that good ozone because the ozone layer in this top layer is protecting us from UV radiation. We'll learn more about that in a little bit. Tropospheric ozone is from human pollution. A lot of it's going to be due to an interaction with sunlight. It's a secondary pollutant because it's formed through a chemical reaction, and it has really bad oxidative properties, which we'll learn about some of those later. So good ozone, bad ozone. We'll learn the details more later in practice. Okay, how might this relate to the burning of fossil fuels? Notice this car is spitting out directly into the environment these primary pollutants, things like nitrogen oxides, things like nitrogen dioxide, these hydrocarbons, and that's exactly right. Burning of fossil fuels is going to make hydrocarbons. We're not going to go into the details of what those are. They're just things with hydrogen and carbon, and things like nitrogen monoxide, which is NO. Nitrogen monoxide will react with oxygen, right, and it'll form nitrogen dioxide. Sometimes nitrogen dioxide also comes out of the car. And that's going to be a choking gas. It's brown and it's gross, right? It's going to make everything in the city really hazy and brown. And that guy, nitrogen dioxide, di for 2, is going to interact with the sunlight, and it'll lose one of its oxygens, reforming nitrogen monoxide with 1 O. And that kind of lone oxygen is now crazy, spinning around, interacting with things. It's called a radical, and it's really kind of dangerous because what it will do is it'll combine with O2, our normal oxygen we breathe, and that'll form ozone. Kind of a complicated situation, but do your best to follow. Okay, some of the impacts of this ozone that are now in our air where we live, the troposphere, that bottom layer. Ozone can damage crops, just like how we can see oxidation called rust on metal. Ozone will oxidize things that are living tissue. We'll see that in this yellowing of crops, and it'll make the crops less productive. It'll also damage eyes by making them irritate. One of the most common things that's in the news is the fact that it impacts humans' breathing ability and causes asthma. And because this is so tough on the body, it'll lower the immune system and might cause infection. Lastly, it'll interact with man-made products that are these big molecules, and it'll kind of disrupt those molecules like rubber or other fabrics, and it can ruin some of our economic activity when we're trying to sell those things. We'll talk more about this figure, which is ozone changing at different times of year and over the planet when we do ozone in more depth. Let's talk about smog. This bottom line here should say common, and so what this says is pollution peaks in the AM or in the morning and is most common, not commute, on sunny and dry days. Why sunny and dry days? Well, sunny, like photosynthesis, which depends on the sun, is going to be related to this sun chemical driven reaction. So photochemical smog is a mix of primary and secondary pollutants formed under the influence of sunlight. It's going to be a mixture of a lot of different chemicals, but mostly it's ozone. And remember, we just decided ozone is going to really form in the presence of sunlight. So in the daytime, when the sun's up, these primary pollutants are going to interact, right? And they're going to form this secondary pollutant, ozone, because of the sun's chemical-driven reaction. We'll talk about why maybe dry days are even worse. What's causing it? Remember, those sources of the pollutants are things like fossil fuels and other industries like power plants and incinerators. Now let's talk about thermal inversions. This is going to be a little lengthy, but do your best to follow. Okay, so thermal inversion is a way that in a valley-like area where there's mountains on either sides of a city, pollution is going to get trapped because the air is going to get trapped kind of like in the bowl between the two mountains, like a food bowl. How does that air get trapped and trap the pollutants? Well, it has to do with how air works at different temperatures. So air is going to be warmest near the surface of the planet at that tropospheric level, right? And as we move up towards the stratosphere, at higher altitudes it gets colder. And different air temperatures are going to be related to the pressure and density of air. So occasionally, especially during valley areas, warm air will move up, and we can see this in this arrows, but here it might get trapped because of the mountains, and it'll trap a warmer air layer up here. That's not happening in this top situation picture because it's not being trapped by valleys and by mountains. Because this warm air is sitting on top in this temperature inversion picture, it's pretty much trapping in any of the air in the bottom layers. And because that bottom layer is where pollution mostly occurs, all the pollution gets stuck and doesn't move around. So if it's in a valley surrounded by mountains, all the nasty air stays in the city. It's gross. Some of the case studies where this happens, and you have some articles on this, are Los Angeles, California, and China, especially in Beijing. Okay, let's talk about industrial smog, which is sometimes called gray smog. This usually will form because of burning of coal and oil, fossil fuels, right? But it's going to have a slightly different composition. Instead of nitrogen being the primary pollutant, we're going to have mostly sulfur-based pollutants, things like SO2, sulfur dioxide, and that's going to form a secondary pollutant with water, sulfuric acid, which is an acid rain. It'll also produce some particulate matter, which is like dust. You wouldn't want to breathe that in. That's actually when it snows, we see that dust kind of look like darkness on snow. And it'll also produce carbon monoxide and carbon dioxide, which are both going to be related to greenhouse gases. Where does this happen? Well, usually it doesn't happen as much in developed areas because we have pollution management strategies to kind of, in our smokestacks, filter out some of these particulates and sulfur dioxides. But a lot of the more now developing countries like China, which are in the process of becoming economically more savvy, and also our lower economically developed countries, they don't have as many of these strategies, and they really do have a lot of smoggy cities. What are some of the factors that might influence the smog production? Well, we know that the valleys and the hills really will influence thermal inversions. More people are going to make more pollution, and they're also going to have more industries creating that pollution. It also will depend on the fuel types. We're not going to go into the super details of this, but different fuels will have different types of pollutants. And also, if there's lots of wind, that's going to move the pollution around. It's not going to get rid of it, but it will move out of that city and kind of disperse. Same thing, rain will bring it down, mostly through acid rain and snow. So these things just allow it to not get trapped in the air. Some strategies. This is our last slide. So how do people deal with this pollution? Really we can go to the source and just do less of the fossil fuel burning. This is tough because it's expensive and it's our lifestyle, but it'll just be use less electricity, turn off the lights, and that sort of thing. And maybe, for instance, a lot of it's car emissions. Maybe not everybody in a household needs their own car, and that's going to be related to the zip car industry. A lot of cities, a lot of people don't use cars, they use public transportation. So lots of different options to reduce that. Switch to renewable energy that doesn't even produce those emissions. Other things, clean up the pollution. This is tough, so this could be filters and smokestacks. It could be somehow trying to get it out of the air. This is expensive, and it's also after the fact. One of the nice things that works in cars are things called catalytic converters. You can see it in the car. We're not going to talk about how it exactly works, but it will remove the emissions from the car. And this is also why states have standards to get your car tested on an annual or biannual basis before you drive around. Lastly, there are a lot of ways we can design buildings to maybe trap some of these pollutants by planting green roofs. So you guys made it through it. Hopefully you learned a lot. Come ready with questions if you have any. And good job. We're done.